Now we start to understand the concept of hypothesis testing, which is the basis of statistical testing. And the basis of statistical testing or hypothesis testing that makes use of the concept of critical probabilities. Remember critical probabilities we discussed in the previous lectures? So what is a critical probability? Critical probability is the probability below which the stated outcome of an event is unlikely to occur. And if that event occurs, that is said to be a significant outcome. So in a normal curve, the value exceeding plus or minus 1.96 standard error, that occurs in less than one trial in 20, or probability of less than 0.05. If a single random value does exceed this value, this is regarded as statistically significant. So procedure for deciding if the outcome of a particular event is significant is called a statistical test. So statistical testing is basically that you are going to decide that if the outcome of a particular event, if the outcome of your experiment that you have done, or if the outcome of your observations is significant or no. And that is done using the concepts of critical probability and using the properties of normal curve. This is our normal curve, and in the normal curve, as you can see, that the central value is our mean value, and this is the plus 1 minus 1 standard error of the mean value. This is plus 2 minus 2 of the standard error of mean value, and similarly plus 3 minus 3 of the standard error, and plus 4 and minus 4 standard error of the mean value. So this is our normal curve of the mean values and their standard errors. So what we can see here is that 68% of the observations, they are lying within plus 1 minus 1 standard error of the sample mean values. 95% values are lying within plus minus 1.96 standard error of the mean value, and 99% values lie within plus minus 2.58 standard error of the sample mean. So these are the properties of our normal curve. Like we have 68% confidence level, we have 95% confidence or significance level, and we have 99% confidence or significance level, which means in the first level, the 68% of the observations of population, they are expected to lie within that interval. 95% means that 95% observations of the population, they are expected to lie within that interval, and 99 means that 99% observations of the population, they are expected to lie within that interval. So this is our normal curve. So how do we correlate it with the statistical testing? How do we use these properties in the statistical testing is that if, as a result of our statistical testing, our results, they lie within this interval of 95%, it means that probability of these intervals to occur is 95%, which is probability of 0.95. So probability of 0.95 is the probability for that event to occur. And what is the probability for that event to not occur? That probability is 0.05, right? And any observations which are lying outside of this range, they collectively, how much probability do they have? They collectively have a probability of 5%, a probability of 0.05, which means that the values within this green area, they are 95 in 100 trials, so they are quite likely to occur because their probability is 0.95. And the events which are lying outside, their probability is quite low. Their probability is critical because their chances are 5 in 100 trials, which is a probability of 0.05. So this is the concept of probability. So any value which is occurring within this green square, within this green area, that thing is said to be non-significant because that probability is greater. Probability is greater than 0.05, probability is 0.95. So anything happening within this green area is non-significant. But anything happening outside of the green area in the red areas, that is considered to be significant. And why that is considered to be significant? Because their probability is low. Their probability is less than 0.05. So this is the concept of the normal curve, the confidence interval, and the probabilities that we make use of in statistical testing. So anywhere, if you're getting the probability of probability of greater than 0.05, we are going to say that our results are non-significant, because greater than 0.05 lies within this green area. And any probability of our test results which is less than 0.05, we are going to say that our test results are significant, because that probability is lying in these red areas where probability of occurring is very critical. Not very critical, it's just critical, because there are levels of the probability. So that probability is critical, that probability is less than 0.05. So if we get any value from these red areas, it means that that value is a significant value. So for that purpose, to understand the concept of statistical hypothesis testing, we have to understand the concept of hypothesis. So what is meant by a hypothesis? Hypothesis is a proposed explanation for a state of affairs or a given problem. So whenever you see a problem, whenever you see a phenomenon, your brain automatically starts to think of the solution, or to start to think of the causes behind that problem or behind that state of affairs, that what has caused that phenomenon to occur. So that is the usual procedure, that you try to find out the reason, that you try to find out the possible explanation for that phenomenon. And this experimental hypothesis testing, that is the basis of experimental science. So in experimental science, whenever you have a problem or whenever you try to sort out a phenomenon, you make a hypothesis and then you test that hypothesis. So these are the steps in experimental science, that first you make a hypothesis for a given state of affairs, for a given problem, and then you do the experiments to test the hypothesis, that if the hypothesis or the explanation that you have proposed, that explanation is correct or no. And based on the results of those experiments, you get your results, that what are your results, whether your hypothesis was true or no. So same goes in case of statistical hypothesis or statistical testing. So statistical hypothesis, it is the basis of statistical analysis, it is the basis of statistical testing, and it follows the same steps, that whenever you have a problem, whenever you have a state of affairs, you make a hypothesis, you make a statistical hypothesis, and then you do the appropriate statistical test to test that hypothesis, that whether that hypothesis is significant or no, and then you make your results. So we are taking the example of skinks, which are lizard-like animals, and the skinks were taken from two islands, a Round Island and the Gunner's Queen Island, and the length was measured. So length of skinks was measured from two samples, one sample from the Round Island and one sample from the Gunner's Queen Island. And these are the symbolisms that we are going to use for these two islands. So one is for Round Island and two is for Gunner's Queen Island. So S1 means sample from the Round Island, X1 bar means sample mean of the Round Island, mu1 means population mean of the Round Island. S2 means sample from the Gunner's Queen, X2 bar means sample mean from the Gunner's Queen, and mu2 means population mean from the Gunner's Queen. So what we did was we took samples from two islands and measured the length of skinks from those samples. So what we found was, what was the state of affairs? The state of affairs is that the mean length of a sample of skinks from Round Island is greater than from Gunner's Queen, which means that the sample mean from Round Island, which is X1 bar, is greater than the sample mean from Gunner's Queen, which is X2 bar. So this is our state of affairs, that we took two samples, and these samples, they had different mean values. One was greater and the other one was smaller. So we want to see that if this happened by chance, or if this difference actually exists in the population. So we need to check that whether this is actually true, that the skinks on the round island, they are larger than the skinks which are present on the gunner's queen, or this difference is just because of some sampling error. So for that purpose, we need to do the statistical testing, and for that purpose, what is the first step? We need to make a hypothesis. So we are going to make null hypothesis. In statistical testing, we usually go with the null hypothesis, that every statistical test that has a null hypothesis which is to be tested during the statistical analysis. So null hypothesis in this case assumes no difference. Null means nothing, no difference, none. So we assume that although the sample means are different, and we saw that the sample means from the round island was greater than the sample mean from gunner's queen, so x1 bar was greater than x2 bar. So this was our state of affairs. So although we have this state of affairs, but still we assume for the moment that the two samples, they have been taken from two populations which have identical means. So although their sample means are different, but the population mean of the round island and population mean of the gunner's queen island is same, which means mu1 is equal to mu2. And in statistics, we go with the alternate hypothesis as well. So we test the null hypothesis, and if null hypothesis is false, then we assume that our alternate hypothesis is true. And alternate hypothesis in this case is that the population means are different. So the null hypothesis is that the the population means are same, and the alternate hypothesis is population means are different. So we are going to test the null hypothesis. We are not going to test the alternate hypothesis. We are going to test the null hypothesis. And if our null hypothesis is correct, then it means that the difference in the sample means is just by chance. Their population means are actually same. But if our null hypothesis is rejected, then we have to accept the alternate hypothesis, which means that their population means are also different. So how we are going to test the hypothesis? By doing the experiment. An experiment in this case is a statistical test. So a statistical test which computes the probability that two samples of their particular sample size and mean difference could have been taken from two populations with identical means. So this is the statistical test that we are going to use. And if statistical test reveals the null hypothesis to be true, we will accept it. And if it reveals that null hypothesis is not true, we will reject it and we will accept the alternate hypothesis. So this is the basis of statistical testing. Now, what is a test statistic? So objective of statistical test that it is to produce a single number, which is known as test statistic. So whenever you are doing a statistical test, you are going to end up with a number. So it is going to give you a number, and by using that number, you have to find out that whether your result is significant or no. So that number is known as a test statistic. So next task is determine whether that value exceeds some probability threshold which suggests rejection of a null hypothesis. So there are published tables of the threshold values, and these are readily available. And if our test statistic is greater than the tabled value at probability of 0.05, because remember, the first level of our critical probability is 0.05. So if our test statistic is greater than the table value at 0.05, then our null hypothesis stands rejected and we have to accept the alternate hypothesis. But if the test statistic that we have calculated, it is less than the tabled value at probability of 0.05, then our null hypothesis is accepted. We are going to use the same example that we are using with the example of skinks to understand that what this test statistic is and how this should be compared with the table value. So our state of affairs was that the sample means were different, and a null hypothesis was that population means are same, and alternate hypothesis was population means are different. So the statistical test is we have to use the statistical test to check the null hypothesis, that whether null hypothesis is true or no. And because these were mean values, so in this case we're going to use the t-test. And when we applied the t-test, we got a calculated value of, let's suppose, 3.56. This is known as test statistic. This value which we calculated after applying the t-test is known as the test statistic. So what is the next step? We have to compare this test statistic with the tabled value. So we have the t-distribution table here, and in the t-distribution table again you can see that we are going to use the two-tailed test because we have used the two-tailed alternate hypothesis. And what is our probability level that we are going to use? It is 0.05. And what is the degree of freedom? Degree of freedom, let's suppose, is 9, and the table value at the degree of freedom 9 is 2.262. So at this value is the table value, right? So this 2.62 and 3.56 is our calculated value. So which one is greater? 2.262 or 3.56? Our table value is greater or our calculated value is greater? Obviously our calculated value is greater. So if our calculated value is greater, it means that our results are significant and we cannot accept the null hypothesis. So null hypothesis is rejected and the alternate hypothesis is accepted. So our result is that population means are significantly different. So using the same example, let's see, we have the state of affairs, the sample means are different from each other, and the population means are supposed to be same in null hypothesis and they're supposed to be different in alternate hypothesis. We applied t-test and we calculated, let's suppose in this case we calculated the value of t as 2.12. So this is our test statistic. So what is the next step? We are going to compare it with the tabled value at given degree of freedom and probability of 0.05 of two-tailed test and degree of freedom of 9. The table value is 2.262. So in this case, our test statistic or our calculated value of 2.12 is less than the table value of 2.262 at probability of 0.05. So what should be our result? Should we accept the null hypothesis or should we reject it? Obviously, we're going to accept the null hypothesis because the probability for null hypothesis to be true is greater than 0.05. So it should be accepted. And probability for null hypothesis to be false is less than 0.05, so it should be rejected. So it should be accepted. And what is our result? There is a non-significant difference between population means. So this is how we compare the test statistic with the t-distribution table, and this is how we get our results. And now the quick definition of one-tailed and two-tailed tests. For example, in skinks, we had the null hypothesis that two samples are drawn from two populations with identical means. So this was our null hypothesis. So in every statistical test we have a null hypothesis which assumes no difference. But the alternate hypothesis is different, right? The alternate hypothesis assumes a difference. So in alternate hypothesis we can either have a one-tailed hypothesis or we can have a two-tailed hypothesis. So in the alternate hypothesis, when we make no prediction that which mean is larger, we just assume that these means are different, then this is known as a two-tailed hypothesis, and that kind of a test is known as a two-tailed test. So in that case, the null hypothesis is that their population means are identical, and the alternate hypothesis is that their population means are not identical. But if we are going to predict that one of the means is larger than the other, then the population with larger mean is nominated by mu1, and this is called as a one-tailed test. So in that case, our null hypothesis remains the same, that the population means are same. The difference is in the alternate hypothesis that in this case we nominate one specific sample to have a greater value than the other. So this is mu1, population 1 is supposed to have a greater value than population 2. So this kind of test is known as a one-tailed test. So two-tailed test means that we are just assuming them to be different. We are not predicting that one specific sample is going to be greater. But in this case, we are assuming, or we are nominating one specific sample to be greater than the other. So this is the simple definition of a one-tailed and a two-tailed test.